Oh, guys, thank you very much. Igor, Vaishak, thank you very much. During my presentation, I would like to welcome you to ask questions as we go so that you don't kind of get confused over certain topics. We will also have a Q&A at the end of the presentation. So the best way to do it is to, I guess, put it into the question Q&A pane that is attached to the Zoom window, or put it in the chat window, and I will try to address it as we go. But at the end of the presentation, we will also have a Q&A session. Also, I have provided a link in the chat window to the document, to the slide deck, in case you want to get off earlier. It's a PDF file. Feel free to share it with your colleagues. There will be also a recording, probably posted later on. It's going to be a big file since it's about 2.5 hours, half-day class. This format helps people to get acquainted with the topics, and probably we would like to hear your feedback, and your feedback is very important. And for that, I also would like to ask you to provide evaluation, to complete the evaluation form to give your feedback. I also send you the details. It should be at the top of the chat. Just go to the website link, enter the class code, just copy and paste, and select the final evaluation. Provide your feedback. It should take you probably around 1 minute. It's just kind of a multiple choice. You select your what you feel is necessary to give your perspective on what could have been done better, or what you would like to hear from us. So I'm with WebEdge Solutions. It's a company that has been in training and mentoring business for 20 years now. And the topics of today's presentation are as follows. So we are talking about developing in AWS. So we will provide a quick overview of Amazon Web Services, databases, Relational and NoSQL, event-driven programming, how infrastructure events and platform events can be intercepted and used to your advantage, working with streaming data, and continuous integration and continuous development in AWS. I believe, Abhishek, if you scroll up in the chat window, go all the way up. I posted it as the first thing when I started the class. You should be able to see it. Okay, so I understand the reason you are here is to probably to get a better idea. We are not going into a very intricate and kind of a little details, nitty-gritty, if you will. But I will give you enough of the, the coverage of landscape, or the tools available, and those points where you can always drill down to get more information. Definitely time is not enough to cover all those topics. Amazon Web Services currently offers around 100 services, and more is in the pipeline. They have started really accelerated the release of those services because they're pretty much using lots of very good infrastructure services like Lambda messaging that you can also start taking advantage of. So what is the reason? So I'm going to kind of put on that hat of a salesperson. We are not in any way affiliated with Amazon Web Services, but I guess I see the benefit. A little bit about my background. I've been in IT for more than 20 years, and I worked with a variety of technologies. Started with Microsoft, getting certifications there, and then I just lost my interest. Switched to Java. I'm a certified Java Enterprise Architect. And when I joined web-based solutions, my focus switched to cutting-edge modern technologies like cloud, big data, Hadoop, data science, analytics. So, I feel that Amazon has done a good job by trying to create this one-stop shop for all your needs. Of course, it's not free, right? Free cheese is only in the mousetrap, right? But it's really cost-effective if you take the whole kind of idea of the return on investment. That ROI indicator is very favorable. You also have competition from Azure, from Google, but see for yourself. So what Amazon gives you, you can also get most of those benefits from using other cloud platforms, but generally they are kind of probably more extended. First, it's on demand, just-in-time infrastructure provisioning. So to get a resource available to you, to make it available, it's readily available, but it's not happening at the kind of a snapping of your fingers. It'll probably take you in a matter of a minute or so, maybe several minutes, but you'll get the resources allocated to you, available, and in most cases it will be fully managed. Fully managed means that Amazon takes care of scalability, availability, and all those quality of service. It's scalable and elastic. Elasticity is very critical because elasticity shows you the latency. When you click on a button to provision a resource, how long it will take to actually scale out, for example, or if your system identifies that there is a problem, how quickly it can provision EC2 instances and maybe some additional resources to meet with the high demand. Critical factor for business analysts, and you probably be also aware that pretty much fixed costs are gone. You don't need to invest into infrastructure. It's available. It's virtualized, available in data centers managed by Amazon. Variable costs, it's a salary and fees of people. You pay for what you use. This is particularly the case with modern additions like Lambda. Lambda is available, but people always get hooked by, how to say, they always get hit by the fact that they just leave a resource running for some time because they just forgot, or maybe there is a storage that you have forgotten to reclaim, to purge, and that potentially might add up to some hefty sums of money. In case of Lambda, for example, it will be truly on demand. So when the service is running, I'm going to talk about Lambda shortly. When Lambda runs, you only pay for the times, a fraction of a time when it runs. Of course, that fraction time would be rounded up a little bit. Amazon needs to survive somehow, but it will be absolutely cost effective. Shorter time to market, you can set up environment, do experimentation, and when you're satisfied, you just clone it and deploy it in production. Global is local reach. It's a way to use edge locations where your clients would benefit from a shorter, fewer number of hops to reach your, you will be closer, your presence will be much closer. And so geographically, those edge locations will be positioned closer to where your clients are, so that they don't have to go through half the globe from someplace far away and becoming frustrated, not because of your service, but because of all those backbones and switches that are sitting between your clients and you. An innovation platform, which comes very much hand in hand with shorter time to market, right? That shorter development velocity, high velocity, shorter time to market, developer agility is all supported, okay? So it looks like some people don't see the link to the document. I'm not sure why it's happening. I send it to all people. Okay, Abhishek, I'm going to send it again because it looks like you really want to get it. So that's my second blast of this link. It has been sent to all panelists, so you should be able to see it. So access in AWS. Now, it looks like you have been kind of sold on this thing. So how you would be able to access the environment? First, you can use the AWS Management Console. It's a browser-based UI, very slick, very nicely done, intuitive, auto-completion is supported, lots of cross-service links. In addition to that, you have command line. AWS tool is available for download, can be installed on Linux, on Windows. And once you get your access key ID, which is kind of your login ID plus what's it called, access, secret access key, and this is a password, you would be able to run the fleet of your servers, your infrastructure in the cloud from your laptop while you are sitting somewhere, maybe in cafe. Right, so of course, security is on you, the onus of making sure that there is no violation of security. Again, it's with you. We're going to talk about this shortly. The responsibility is a shared responsibility model. But it's an amazing what you can do using command line. Pretty much it covers most of the services. The command line is pretty intuitive, so you can script, you can shut down part of your infrastructure if you feel that it's warranted. You would like to take it offline, or maybe you would like to deploy some additional resources. Everything can be done from command line interface. And it's not necessarily running in the cloud. Whenever you provision EC2 instances, they automatically have with that tool bundled. But you can also download, install it, and run it from your home computer. It's a great, fantastic tool. Probably it's a little bit of a headache for your security people. From the DevOps perspective, it's a great tool. From security, it's a nightmare. Probably there should be some constraints. So governance definitely should be in place here. Okay. Guys, let me repeat this. It looks like some people are confused. Maybe they have just joined. I have already posted the link. I sent all the, just give me a second. Attendees, okay. They call it panelists. I see, sorry about that. This Zoom thing, it's just really, it's just a pain in the neck. All the defaults are just screwed up. We've been using Cisco's product, GoToWebinar. So intuitive, so much better. Zoom really has to catch up. Sorry about this, guys. It's my bad. Okay, and yeah, the problem is that you always have to unlearn. So when you switch from one product to another, all of a sudden it's just totally new ball game. So again, so that's the link, and okay. Yeah, I have to read the small fine print, drop down, all panelists and attendees. I see it now. Okay, guys. So moving on. So next thing. So let me make sure that we're good. Okay. Yeah, we've got around 200 attendees, and I guess I just need to make sure that I don't miss anything. I believe Q&A panel would be better for me to get your question and try to answer it as we go. Chat is a little bit too chatty. Okay, and you also have the support, the regular support from AWS in the form of software development kits, SDKs for, like in terms of Visual Studio plugin for .NET Microsoft developers, as well as for Java Eclipse plugins, meaning that you can drive your cloud activities again from your desktop, from your laptop. So you've got all those three choices, and you can select the one which is more appropriate. By the way, what you need in all those cases, you would need, of course, access to Amazon. You need to have an account. And when you have an account, you can get the ID, the access key, and the secret access key, which is a password. So shared responsibility, that's critical piece. You need to understand who is responsible for what. And there is no finger pointing. It's just cast in stone. What happens is Amazon is responsible for a number of things. Mostly it's in their infrastructure. They also enforce the perimeter security, meaning that that distributed denial of service against your server would be kind of dwarfed. It would be protected from Amazon. They will be starting dropping those packets if they realize that the pattern of requests going to your IP address and ports falls under the category of distributed denial of service. So they can guarantee you that intrusion detection as a very outer perimeter would be enforced. But having said that, it's not the whole story. You need to be aware that you are responsible for the rest of the things. Security is of paramount importance. You shouldn't be worried that somehow someone in the cloud would be able to switch the network card into promiscuous mode and trying to capture your packets. It's definitely not going to happen. But it's your responsibility, it's your due diligence to ensure that you enforce the regular policies to secure your accounts for user access control, roles, who is doing what, application passwords, their renew time, length, complexity. You are also responsible for operating system patching if you are using your own unmanaged services, meaning those are services that are managed by you and not by Amazon. For the most part, resources are managed by AWS, so those OS patching, security, scalability, everything is taken care of by Amazon, but you are responsible for patching operating system of your EC2 instances, because that's critical. You'll definitely get all the support. You'll have some sort of a message like advisory notification there is a security breach, or definitely there is a patch that is mandatory, critical to fix a particular bug. So it would be your responsibility, as well as network configuration, public, private, and virtual private clouds, that the facilities that is available to you by default is a place where you need to spend some time trying to partition your application, create tiers, and you would be able to take up your end of the security. Amazon has the global presence around the world, and they are opening geographical regions they activate. And as of early 2019, they have 20 of those. Each of those geographies is represented by 2 or more availability zones, which are actual data centers sitting on independent power grids, such that power outage in one part of that region is not going to affect the other. Of course, if I guess the worst come to worst, then you will be out of, out of luck. But you can also have a deployment in another region. So in this case, it will be probably a different country or different parts of the country, geographically quite diverse. As you see, 60 availability zones, so data centers are available. So if you do a simple math, 60 divided by 20, you will have about 3 data centers in the region. Some services operate across AZs, for example, S3. Other services would require you to set up certain conduits or bridges between availability zones. That's what you would need to do. There would be an example slide for that, how you would make your relational database of choice available across AZs, different availability zones, so that if one availability zone is affected by a power outage, then the other one will carry out the work. 100 services, and that's what really makes Amazon Cloud Platform very attractive to developers. You have pretty much services around all the major IT concerns, whether it's security, compute, storage, networking. You have a choice between relational and NoSQL systems, analytics, the Internet of Things, the IoT, critical. And now Amazon is very aggressively, they're very high on machine learning. So they're adding stuff that would help you build chatbots, recommenders systems, language translation, and what's not. Certain things are still in preview, in early beta, probably alpha. They're trying to minimize impact on those services, but looks like they're very high. There are currently around 12 machine learning services. So your business analysts, in addition to what you currently have, would love to see those. They are quite flexible, easy to use, good, I guess, positioning in terms of pricing points. What's important that Amazon gives you the best of breed in hardware. They have a number of vendors who are ODMs, original design manufacturers, not OEMs, original equipment manufacturers, who probably be the same OEMs who are in the business of creating, designing, and building hardware as per Amazon specifications. And that means that you will have specialized hardware, which will be much more efficient compared to what you could do on-premise, even though it's in the cloud. For example, for Apache Spark, like Hadoop product, which can do ETL, which can do machine learning experiments, and lots of other things. They have a specialized Spark-specific machine, which has 1 terabyte of RAM, lots of CPU, and that machine would pretty much be the cluster of the capabilities that you could have on premise. Okay, so that's a very important factor, meaning that you can find yourself large or extra large hardware, probably a dedicated server. It will be probably costly. It will probably cost you $1 or $2 per hour, but it would definitely be a very cost-effective way if you run some ad hoc jobs. By the way, you have to be aware that not all services are available in all regions. So be aware of that, because of that. Remember that first slide, global as local reach, as the edge locations, would not work. You would need to have kind of some discussion, probably get in touch with Amazon how to bring a particular service closer to your clients. And so there are always fine print. And again, you probably is aware that cloud is a very shaky place. So you might have problems with stability. There would be window of maintenance. For maintenance, you might have some hiccups in I don't know, serving your clients. So don't expect it to be rock solid. But if you really think deeply and widely by trying to engage the best practices and recommendations from Amazon, you will be, I guess, pretty safe. And Amazon is getting better. Earlier, they had some problems, their fair share of those, not without such things, but they have grown into something which is really appealing to developers. the compute services and networking. So you have a bunch of services, starting with the virtualized computing on cloud, EC2, which are actually virtual servers that you can provision on demand and start using those. AWS Lambda is what I mentioned earlier, and this is something that you should really pay attention to. Lambda is very cost-effective. You can think about it as a trigger in a database, a relational database. So whenever you insert, delete a record from a table, and if it has a record, update, delete, or insert, that code would be invoked by that RDBMS in response to that action. So you can do some validation, and you can do integrity check and enforcement and what's not. So that's the idea behind Lambda. Lambda is essentially code that you can write in Node, in JavaScript, in C#, in Java, in Go. And that code would be automatically deployed on a fleet of Lambda servers. It's kind of a serverless architecture, and with no admin involvement on your part. It will be running the job, and when it's done, it will be taken offline. Of course, it will probably be cached for some time, depending on the workload, but it's very responsive, and it's very reliable, and it's scalable. The Docker container services would help you with this approach for DevOps, where you would like to have agile practice to deploy a fleet of servers. It's much more efficient compared to EC2. EC2, you get a virtual machine of some sort. So Docker, as you know, will allow you to have high density, high performance, and quick startup time for your services. Auto scaling helps you to automatically, based on some thresholds on some events that we're going to talk about shortly, would help you to provision additional resources on demand. Whenever there is a peak in client requests, the system would identify if the CPU or probably bandwidth or some other parameters that you can configure using wizard-like, very intuitive wizard-like workflows. You can set a threshold to get triggered and automatically provision additional resources. ELB is the way to front a cluster of your machines, elastic load balancer. Virtual private cloud is a default way to deploy. You have a default one, and it's up to you how you want to partition your application, your solution. It's great to perform partitioning by tiers, where you would deploy your application like Frontier, your business logic application server, and your databases. The Amazon Route 53, it's a domain service which will allow you to redirect traffic potentially from one region to another. Elastic Beanstalk, it's a platform as a service. So it's a way for you to materialize or implement that lift and shift type of migration of your resources on-premise to the cloud. You will have probably, I'm coming from Java background, and it can be, of course, your packages in other systems. But if you come from the Java background, you would know that your web application would be bundled as a WAR file, web archive, or ER file. So you can do that deployment in Beanstalk with no hassle. You will just specify the type of application server you would like to serve your application. You would upload it. Probably it'll require some tweaking, configuration changes, but for the most part, it will be minimum effort on your part to perform migration. That's very appealing. And by the way, Beanstalk takes care of scaling, security, and it's very much offhand type of resource. It's fully managed by Amazon. All you have to do is just to start using it. And that would probably be the first low-hanging fruit. You engage people to start using Elastic Beanstalk, and you are off to the races in practically no time. Okay, EC2, let's take a closer look because you have more options here. The main part is that you have a choice of bootable Amazon machine images, or AMI for short. It's an operating system of your choice, plus optionally some pre-installed software. And there is a marketplace where you can get for free or for some pretty nominal amount technology stacks built on those images. Those are bootable. You just specify the type of machine that you want to use, like the profile of hardware, extra large, large, medium, small, and what's not. And that would be the piece of hardware. And you would deploy that AMI, whether it's Windows or whether it's Unix. You can create your own AMI, which you can deploy later on. And security would be managed through security groups. So it's a virtual firewall, sort of a table, which would show, would allow you to open certain ports and designate the whitelisted source IP addresses, so that it will be only coming from your tier, from your applications that has its own IP address. By the way, those IP addresses would be non-routable, not IP routable. It's like kind of a way to protect your environment. You would only expose your endpoints to the outside world, and that would be HTTP or HTTPS, and all other ports would be closed. Right, and you are also protected by the perimeter security, which is in line with the shared security responsibility model. Lambda allows you to run, by the way, Lambda comes from that functional programming where you have that inner function or Lambda function, which doesn't even warrant to give it a name. It's just some anonymous function which just has some behavior. And that behavior would be attached, as I said, as a trigger of some sort to a particular event. It would be kind of a listening for things like something happens with your resources. You have uploaded a file to S3. S3, it's a storage service, simple storage service. It's simple as it was originally conceived, but now it has grown into something more interesting because you can build a whole marketing static website by just uploading resources to a bucket, which is like a folder, and you will attach, you just specify the endpoint index HTML page or error page with JavaScript code, which you would expose to the whole world. It would be publicly accessible point, and whenever you upload something, that will be instantaneously available, as long as you have the right policies to make them available. And you can also have more complicated activities. And Lambda, when it was introduced, I believe it was 3 years ago, or maybe longer, it was a very good answer to lots of things because people solve those problems by deploying EC2, their own applications, and it was lots of hassle, lots of complaints, and people got, I guess, frustrated by having to do certain simple things by going through those hoops of system administration and provisioning and securing. Lambda is the answer. So whenever you have a particular solution that you need to solve, start looking at Lambda right away. It supports choice of languages. I mentioned that earlier. And it's your friend. Okay, if Lambda doesn't fit the bill, then probably EC2 would be your answer, or maybe a Docker image using that Elastic Container Service. It's very cost effective because you only pay for what you use. Yeah. And by the way, we will have a short break at the top of the hour for 5 minutes so that you can stretch your legs. I'm not going to talk for 2.5 hours or so. Okay, so we will do that. Okay, Elastic Beanstalk. So we talked about this, and Elastic Beanstalk, it's a PaaS. It's a platform as a service. It supports all those programming languages and platforms. You just need to specify what type of application it is so that it would know what runtime to provide on the startup, and you will be, I guess, all good. So Beanstalk gives you everything that you would expect from PaaS. For example, Google gives you that Google App Engine, similar facility or capability. Load balancing, auto scaling. It might be a little bit probably costly because they would probably add some price components there, but it's a very good way to start. So if you have a very critical time constraint project that you would like to complete as soon as possible by migrating your applications to the cloud, the Beanstalk platform is the way to start looking at. Autoscaling is part of that compute and networking set of services, which is very tightly integrated with the rest of the infrastructure, and it helps you to automatically and elastically scale your application horizontally. That's the main idea. There is a threshold we talked about, like CPU usage, maybe IOs, when they start kind of skyrocketing, you can affect that peak in demand and get autoscale scaling service provide you with additional components. As you see, autoscaling is not running on its own. The last bullet mentions that it works hand in hand with the CloudWatch service. CloudWatch essentially is a perimeter service, and it monitors collects lots of metrics around the runtime of your application, and autoscaling is essentially subscribing, and through that policy files that you have set up, those rules that you have established when to scale the threshold, the level of threshold, the CloudWatch will be feeding continuously that information so that the autoscaling would trigger that particular event to provision more resources. Virtual private cloud is the way for you to create an isolated kind of a sandbox type of environment. You can have one VPC in one region, but VPCs can span different AZs within this region. So 2 or 3 AZs would be covered by that one VPC. Inside the AWS infrastructure, they use the accelerated transfer, like hotlines between availability zones. It's a secure tunnel mode, even though it goes through kind of a, you can say, the internet infrastructure, but IPsec create that VPN, virtual private network, across your machines. And it's secure, it's fast, and it would help you create highly available solutions in the cloud. S3, it's an object storage, and a lot of solutions are centered around S3. So S3 is available through a command line, AWS tool, RESTful endpoint through SDKs of your choice. And it can also be a very good addition to lots of solutions, as I said. For example, if you deploy your solutions on a Hadoop cluster, S3 would be used as the storage. Same comes with machine learning. S3 would be the source of the files. You upload files to S3, and then your application would pull those files from S3. You pay for what you store. I believe they have Amazon has got charging you for upload time and for download time. There might be some, I guess, constraints, some qualifications for that, but S3 essentially has become the place where you pay for what you store. It's quite efficient. If you need something more advanced, there is Glacier, which is kind of a slow S3, which is dramatically cheaper, and that's I guess for you to consider if you would like to store some historical data that you would like to put on a tape. And so you've got some choices you can create to workflow where some objects from S3 would be cataloged or uploaded to that Glacier in kind of a low speed but very cost efficient solution for you to maybe comply with some regulatory compliance requirements, like to keep historical data for 13 months so that an audit can, when the audit happens at your organization, you would be able to pull out the data. Databases choices, you've got relational databases. There is a wide range of those. You have NoSQL solutions. The flagship product is DynamoDB. You can also deploy solutions of your own if you want so, like MongoDB. It's part of that, those EC2 machine, Amazon machine images that you can boot and use. Elastic Cache is just generic solution for caching. By the way, caching is your friend because caching would allow you to avoid sometimes costly hits on a backend system. So caching, it's a sort of a proxy for your backend. It can be read through, write through, and caching is extremely cost efficient. It supports terabytes worth of data, and Elastic Cache supports interfaces to. It's very similar to what you would have with Redis or Memcached. So if you have used those caching solutions, you're pretty much off to the races using Elastic Cache. Redshift, it's a warehousing system which has lots of BI tools attached to it. RDS, as you see, there is quite a diverse list of available databases. Really, you have pretty much Postgres, you've got Oracle, SQL, and just give me a second. So people have a question usually, if I have a license for Oracle or SQL, Microsoft SQL Server, how can I use it? Yes, definitely. You can use your license. You bring your own license, or you can use any of those instances which have Oracle or SQL Server installed, and there would be some fraction portion of the license enforced when you run the instance of that database. A very interesting choice is now with using Amazon Aurora, which is MySQL compliant. They really want to position it as an RDS of choice. And they've got other choices, Postgres, MariaDB. It's RDS is a managed service managed by AWS, and where administrative tasks such as backups, patch management is taken care of by AWS. Again, it's a very valuable thing. You are focusing on just uploading your data, inserting data, and then using it. And lots of that stuff is just magically, transparently being handled. And in terms of high availability, if you don't do this arrangement, then you are creating a single point of potential failure. If your database is going under for whatever reason, then you're out of the water. So Amazon offers a whole catalog or blueprints of solutions, best practices that they provision as just it's open for the public. Of course, you can engage the solution architects from Amazon who would give you probably a deeper, more fine-tuned solution. But generally, if you have a kind of a ability to read the architecture diagrams and understand what transpires, and you'll probably have some sort of pre-production testing. You can employ those blueprints and implement your solutions based on that. So let me just quickly go through a number of things here. I would need to activate and update that here. So we're talking about two availability zones. So this is somewhere in a particular geography, it's a region, and everything happens inside a VPC, a virtual private cloud. And inside it, you go to availability zones, availability zone 1 and availability zone 2. So those are two data centers. And your solution requires that you deploy some sort of relational database at the back, right? So that would be the master node. And you would have the slave, kind of a hold spare, which would be continuously receiving synchronization blasts, those synchronous replication. So data would be synced. So whenever there is an insert or update on the master, there would be the triggering operation, which would be synchronizing. So if something happens with the master and master goes under, the slave would be automatically promoted to become master, and then with some window of opportunity, you will be able to bring up the master, which would become the slave. So as you see, we've got auto scaling. It's just in addition to what we are discussing here. This is an example how you would add EC2 machines. So those are EC2 machines. Currently, there is one in each availability zone. But if something happens and you need additional resources, that auto scaling based on CloudWatch metrics and based on your rules, it would provision how many machines. It can be one at a time, or it might be a whole bunch of those. An elastic load balancer sits in front, so your traffic hits elastic load balancer. And there would be a slide which shows how elastic load balancer helps you with triggering some activities. So elastic load balancer monitors all the activities. It does some sort of round robin or recently used or whatever policy strategy it wants to use. All the statistics metrics are collected, and a load balancer is that highly available elastic load balancer. Whenever you see elastic, that means it's managed service, and it has the capacity to scale without your involvement. Okay. Quite a noisy slide now, so I need to remove the clutter. Yeah, much better. As I said, we will have a short break at the top of the hour. So in about 10 minutes, we will have a break. DynamoDB is a NoSQL, not only SQL solution. It's their flagship. They put a lot of effort in designing this system to be extremely flexible in the operational aspect, as well as robust from the infrastructure point of view. So it provides consistent single-digit millisecond, like maybe 5 milliseconds latency at any scale. But it doesn't provide a consistent view of data. So in terms of that CAP theorem, that consistency, availability, and partitioning triangle by Eric Brewer, it's eventually a consistent system. You can enforce data to be very consistent at the expense of availability. It's a tunable parameter, but out of the box, DynamoDB is distributed across a number of shards to ensure highest throughput and scalability. And those shards definitely would need to be synchronized to provide a consistent view of your data. But the system is available, highly available, and it's partitioned. So it takes that that edge, consistent and partitioned, out of the three. It's a key value. It can also be used as a document data store. They use SSD, solid state drives, which is kind of a slow memory. They support very high throughput, up to 100 regular um, thousands of IOPS. And because of sharding, splitting horizontally your data, they are able to remove kind of a hotspots. Your data modeling, I guess, skills are at high premium here because you need to design that primary key and secondary key such that it would not create contention points where everything is just centered on a particular shard. You need to, I guess, do some upfront investment, like logical database design, so that you are not affected by people going to the same segment of your data all the time. Some people are a little bit reluctant to adopt NoSQL. It's just, yeah, there is a question, what is sharding? Sharding is about to horizontally partition your data. So the system shard has been coined by Google engineers, and it's just a way to say, I would like to horizontally partition my database. By the way, RDBMS support sharding as well, but it's called horizontal partitioning. So let's say you would say the sharding would happen when the number of records in the table reaches 1 million. So 1,000,001 record would be allocated to a new shard. So a new shard would start with one record being there. And then the system would essentially load balance requests, and it would keep everything under that limit. So that you have a number of shards, which would be essentially, if you take them together and stack them up, it would be one big contiguous table. But that is not very good as a solution. For that, you would just think about it as slicing and breaking it horizontally and spreading them out on a cluster of machines of the infrastructure allocated to support DynamoDB. Okay, so that's what sharding is all about. Let's compare side by side relational and NoSQL solutions. Right, as I said, most of us have been working. I worked in insurance. I worked in banking sectors. Everything is around using relational databases because they support ACID properties, right? Transactional support, all those good stuff which NoSQL databases do not support. Because in order to achieve that high throughput and that flexible schema and what's not, they have to forgo, they have to compromise on certain things, right? And you have to supplement your relational databases with NoSQL solutions. Right, and in many cases, if you really understand how what happens if you have a very good understanding of your data flows, your data properties, what you want to achieve, you probably can switch lots of use cases from a relational database to NoSQL. But I guess if you have a very mission critical database requirements where I guess consistency and availability, as well as ACID properties, reliability, and the standard interface, all those factors are very important, which speak in favor of RDBMS. So let's go like side by side and compare those apples and oranges. So we've got normalization as a critical factor as part of your, I guess, design upfront, where you would have your tables in the third normal form. NoSQL solutions are denormalized, and they perform better if data, excuse me, if data is really denormalized, where there's some repetition in data. And usually vertical scalability is the only option available for SQL, even though horizontal scalability is available through synchronization, but it will be costing some extra money for you. Two-way scalability up and across is available. Relational databases um, adopt the standard SQL 4GL language, fourth generation language, which is a way to people pretty much know SQL right away. After a couple of hours working with that SQL syntax, you will be quite proficient. Most NoSQL systems, they have their own specific incarnation of some sort, which would resemble some sort of like PLSQL or TSQL type of language. But at the same time, many of those have adopted SQL as an alternative or primary system. So there is a question, how to perform joins in NoSQL databases. Yeah, that's a good question, really. And what you need to do, you would need to implement it in your code, in your application code. And that's what's happening. So you would need to have, if you would like to do in a join, you would need to plant or insert that kind of a primary key as a foreign key in another table of NoSQL table. And you would pretty much reconstruct that code's idea of relational algebra. You'll have primary key, foreign key, and you will be able to do that. But it will be up to you. It will be on your kind of a table. On your plate to implement this solution in your application. So that's the answer. ACID properties are supported, and that's what really makes relational databases shine. NoSQL just shy away because it really gets in the way with the throughput. Strict schema, again, that's the forte, that's the up feature of RDBMSs. Schemaless on the NoSQL side. It also comes as flexible schema, schema on demand, or no schema at all, things like that. And SQL databases, they are available and consistent as per CAP theorem triangle by Eric Burr. And most NoSQL systems are eventually consistent. They're partitioned, but they are not consistent right away because that availability comes at the expense of sacrificing consistency. So the system would catch up eventually. It will have everything just kind of balanced out, and you have eventually consistent view of your data. It might take a minute, it might take several seconds, but generally PA is the way for NoSQL systems. So let's take a break for 5 minutes, and we will continue after that. Okay, let's continue. So we are done with this table. There is more you can add to both sides, but I guess it just captures the essence of the differences. And as you see, NoSQL solutions, they supplement relational databases, and they should be in your toolbox as a developer, both systems, depending on your use cases. For example, that if you need an inner join, a very efficient one, ACID properties. And the good thing is that Amazon gives you access to both sides of the world. So you don't need to kind of provision, purchase licenses. You already have all those systems available. All you have to do is just to create an interface to the system at the backend. So messaging, very critical for building asynchronous communication channels. And on this front, Amazon gives you all the necessary services as well. So you've got SQS, simple. Everything is simple. It's not so much simple because simple it was originally, and over the kind of a time of the service being in production, they added more services, integration points, and no longer it's simple. It's really messaging capability, which might not be exactly what you would expect from a messaging system, and I'm going to touch a couple of points as we go, but they do a good job. And you can always just ignore that simple, think about it kind of elastic queue service. That would be probably a better way to name. So we've got queuing, notifications, mailing, and we've got Amazon MQ. There would be a slide to discuss this in more details. So SQS and S3 was the first two services that were launched by Amazon, I guess, a while back, around 2007, when they started selling their compute services to their clients. You've got a choice between two message delivery options. You've got standard queues and you've got FIFO queues. And at this point, you see there is a dichotomy between what you can achieve with standard queues. Pretty much it's high throughput, fire host type of throughput, best of effort. So whenever you see that, that means that there is no guarantee to enforce message ordering. So there would be, but definitely there would be at least once delivery guarantee. So if the message has been put on the queue, it would definitely be available for consumption. You might never consume it. That's kind of your problem, but they really go out of their way to ensure that it will be available for consumption. So no guarantees for ordering. It's not the end of the world. You can always implement something on your application side. There's a way for you to add some meta information to every message. So that would be kind of a sequence number, as if it was kind of a TCP/IP type of communication. And you would be able to ensure the proper order of those messages. It's just a small tweak of your solutions. You would be able to enforce message ordering on your own side. But if you just don't have time, you just don't trust the system, then you can use FIFO. At this point in time, you will be probably capped with lower throughput because FIFO would definitely first in, first out would guarantee that the message as it was produced, it would be consumed exactly once in the order that it was inserted on the producer side of the queue. Okay, so you would expect that messaging queues are FIFO by default, but it's not the case. So you would have through configuration stage, you would be able to see what options are available and select the one that best matches your requirements. So there are a couple of questions. Some examples of using SaaS for AWS. SaaS is a software as a service. I guess I don't know, maybe S3 as a SaaS. You already have a service, you just upload files and it's made available. Nothing is done on your part. I would say S3 would be a SaaS of sorts. But the good thing, you've got choices, right? You've got choices between this and that. It empowers you. It gives you a chance to succeed in certain situations where all of a sudden, maybe very well in the game, you identify that a particular solution either not scalable and doesn't have throughput. It's just doesn't match the use cases that you all of a sudden have uncovered. That's what Amazon gives you. You don't need to rush and start purchasing some software, waiting for the license or that piece of hardware to arrive, and losing your customers, your reputation. Pretty much you're going out of business because of that. With Amazon, in the same way as probably with Azure, with Google Cloud, you are in the driver position. As long as you know what you're doing and you can always adapt to changing business requirements, business environments. So SQS is a managed service, and one thing that you have to be aware, and you always have to be on the lookout, you have to unlearn certain things and learn new things. So don't be confused by, it's a messaging service, so whenever I consume a message, automatically a message would be received, would be deleted from the queue. That's most of the queuing systems, that's the mode of operandi, if you will. So whenever you send an acknowledgement, yes, I have received that, system would delete the message. In case of SQS, you will have to do it yourself. As a consumer, you have read it, and then you'll have to delete it. Okay, so 2 operations, meaning that there will be 2 hits on the SQS, not 1. And in order to deal with that distributed nature, because SQS, as long as you see that it's a managed service, that means that this system is partitioned and it's distributed across a cluster of machines. So potentially you might have situation with the fact that message has been consumed by a particular consumer, but the consumer has not yet deleted the message, and another consumer comes in as a thread of execution and reads the same message, by potentially creating a duplicate. Right, and then the first one comes in and deletes the message, and maybe there is a third one which again was able to make its way to that consumer side and read it for the third time. So in order to prevent this, they introduced what's called, it's quite confusing if you read it, visibility timeout. The default is 30 seconds. That visibility is for the original consumer. So when the consumer reads the message, it puts a lock on that message, meaning it becomes hidden, not available for being being visible to other consumers. Right? So it's only visible for the same consumer. I don't know how best it may be just locking, but for some reason, I guess marketing folks at Amazon decided to call it visibility, meaning it's a reverse of visibility, invisibility timeout. And then you'll have 30 seconds by default, you can send it more, for that original consumer to delete the message. So that the lock would be relieved, a message would be deleted. Okay, so many people, they start working with SQS and all of a sudden they just got stuck with that visibility, or they just don't read it, and it becomes evident later on when all of a sudden quality of the service is not what you would expect. So this is what you can do for SQS in terms of available actions. This is the Amazon Management Console. That's the UI. You see that you can send a message. There would be a text box for you. You can view messages. You can delete the queue and subscribe to SNS. You can also configure trigger for Lambda function. Right, so Lambda would be reading a message and whatever you want to do with it, kind of a smart dispatcher, if you will. And the same commands are available from the command line. So that's the first, I guess, example of using AWS command line interface. AWS, it's just a tool which runs on local machine or in the cloud. In fact, it's just a RESTful client which makes a REST call to Amazon endpoint, and whatever you specify as a command line arguments are passed on. So The first command would create a queue, you give it a name, and the properties would be sitting in the JSON, in that my file JSON, which would be sitting locally in the working directory from which you execute the command. Then you can put a message to that my queue. You specify the body, and you can also set attributes, again, expressed as JSON file, key value pairs. Attributes are important. It's kind of it would make it as part of the head information, meta information about the message, and you can always read it and get, that's where you would be able to add maybe sequence number so that you would ensure ordering of your messaging. So as you see, you've got pretty much what you would expect in like other messaging systems like WebSphere MQ, that MQ series from IBM, things like that. SNS is a notification service, fully managed, which allows you to implement the pub/sub type of protocol, and you can have topics available to multiple clients. You can have mobile devices, email, SQS, lambdas subscribing to the topic, so that integration pattern called fan out is available. You just sending out the same message to a number of clients. So here's an example of what you can achieve, just generic architecture of SNS. As you see, we've got a publisher, and the publisher through some command line interface or just RESTful push would make the message available. It's sort of an event, and that event would be put on an SNS topic. And what happens is that at this point, you will have subscribers picking up that message and completing the workflow. Many people who come from the Java side of the world, they have been exposed to JMS, Java Messaging Service System. And ActiveMQ is an Apache product which was written in Java, and it supports all that, all those interfaces. I believe JMS2 is now supported as well. So Amazon MQ is built around that. Probably they hardened it in some parts, but in essence, your experience would be the same. It's a message broker, and if you have a client written in Java, you can use JMS libraries to interface with that system. It gives you that interoperability right of the box. So if you have your solution deployed on-premise, which uses JMS and some other specific JMS service, whenever you deploy your application, you don't need to change anything. You just need to create queues and change some other configuration, but the rest of your code would stay the same, whether it's queue-based or pub/sub type of operations. You have command line interface, RESTful. SDK is also supported. Event-driven computing, that's a very interesting part. Essentially, you can think about cloud as a system which produces signals. Those signals are events, something happening, and that event is measurable, it has a time, and it has some semantic meaning to the rest of your infrastructure. This paradigm helps you create loosely coupled, scalable solutions. It's asynchronous in nature, and you've been probably using it. And events or messages or signals, they have sources and destinations, and they have payload. That payload can be introspected. It's kind of a transfer object, which helps you to realize very complicated integration solutions. Right, so message can be retrieved on demand, or there would be callback, so that if you make yourself a subscriber to that particular message, you'll be seeing that message coming through that callback method. those people who are responsible for creating microservices type of architecture, they would love it because with your very little input on your part, you would be able to create very reactive type of architectures. So that reactive programming can become part of your infrastructure. And that loose coupling definitely would allow you to build highly available systems and very robust too. So in addition to your applications that generate events, more importantly, you can subscribe to a wide range of infrastructure events that the Amazon Cloud platform exposes, makes it available for programmatic access. Like whenever you operate with S3, insert a record in DynamoDB, there are a number of things that might be happening. CloudWatch events, which are tied to autoscaling, would be made available. A low storage event, IOs on your EC2 instances, and many of the events, they're available for providing a hook. If you're interested in those events, you can intercept it and you can react to it. So you have that very adaptive or reactive architecture that is smart, can adapt itself in case of need, and release resources as you don't need those. So here's an example borrowed from AWS documentation, which requires, I guess, some description. So we start here at the load balancer. Just give me a second. Nope. There we go. I'll probably increase the size just to. There we go. So we start here at the load balancer. So our clients are accessing our application deployed in Elastic Container Service. So we've got a bunch of instances running here, Docker images. So we've got a bunch, 100,000, whatever is required. And all of a sudden, we've got a problem with our application because there might be a particular use case where we haven't provided enough, I guess, logic, and our application slows down. It doesn't provide, maybe it just becomes so CPU bound that, or garbage collection kicks in and it's create the an appearance that our application is no longer responsive. So all those behavior would be registered at the Elastic load balancer, because load balancer would be supporting those socket connections between the client and the entry point on the load balancer and the outgoing. So it will see that there is no response coming back within a specified interval of time. So that's where SLA would come into play. You would say if the response doesn't come within 10 seconds, it violates our SLA with our clients. We need to take some drastic actions. And how it would be possible to implement in Amazon. So CloudWatch would be monitoring those metrics. And whenever there is a high latency happening, that event would be raised and registered by the Cloud Alarm. So that's the first thing. Second thing happening, that the event is identified as happening. That event is pulsed to CloudWatch alarm. It gets registered, and CloudWatch publishes an event to SNS topic, right? So then there is a Lambda function, which is a subscriber to the topic, kind of a high latency. It listens to that topic, and whenever there is an event, message is published there, Lambda function is triggered. It executes the code which has been built around static profiling tool. Profiling means some sort of maybe Java or .NET introspection, checking what's happening, is it a garbage collection, do some introspection into what is actually happening. Maybe we need to change the Java garbage collector policies, or maybe there is something else. Maybe CPU is really skyrocketing, and we just need to probably increase to scale up our hardware, so that we, instead of using small or medium-sized hardware profile virtual machines, would use something bigger, maybe large, maybe extra large, so that we've got more CPU, more memory, and there is no constraints. So that thing is essentially, we've got a full cycle. We've got complete visibility into how we can help our clients to get the best service we can. And as you see all those services, you would have to implement yourself on premise, so that you would have something like that. Again, it's not a big deal. You would probably be able to do that, but why bother if you have something that already available to you? There is a question. Could AWS provide events on MongoDB on its own? I think it would be application type of event. So that, let me highlight my point. Let's say you've got MongoDB here, right? Running on those instances. And all of a sudden, disregard this one, disregard the CloudWatch, you can simplify, right? And you know that there is something wrong. As long as you can formulate it and wrap it up as an event, you can publish this event directly into a particular topic. Okay, so that's possible. Essentially, you create SNS client, and you would it would be MongoDB running on, let's say, EC2 instance, or it may be a Docker container. And then you would have a Lambda, which would reacting to that particular event. It might, I don't know, do something in the container with MongoDB, or it might do something else. But that would be an example of application-driven event. But the same logic applies. Okay, make sense? Okay. Okay, moving on. We've got another example. Of an event being generated when you've got an object uploaded. So we've got, again, let me illustrate, because this diagram might not be quite descriptive. So everything happens here. Maybe I'll, rather than just drawing, I would just use a spotlight, okay? So everything happens here. This input, we are uploading some objects, and this object has been uploaded by a client or by yourself, and you subscribe to this event, like put or post. This event is automatically published transparently from you to an SNS topic that you can specify. And then it uses that fan out approach where you've got two queues subscribing, SQS. And there are, on that, this is the producer side. The SNS acts as a producer for those events messages. And the clients or consumers of SQS are pulling out messages from the consumer part. And what they do, I guess the logic here is to use file encoders, so that it would be probably maybe decryptor, or it might be some sort of a codec translation. You've got file uploaded in, say, in one media format, and you would like to convert it into MP3 or maybe another format. Then what happens, those files would go to the S3 bucket where the new file has been uploaded. It performs decoding or changing codecs, and it would upload or push the file out to that processed files bucket. Okay, so of course it would be different from this one, right? Otherwise it would be like eternal cycle. So that's, again, on your part, all you have to do is just to provide those encoders or decoders, and that's it. And you just use lots of available hooks that you can subscribe to and get notified about an event of your interest, react to it, and complete the job. So that's what S3 event configuration page is. As you see, the system recognizes those are RESTful type of verbs, HTTP verbs. You can put an object, post, or you can copy inside something which I guess you would be interested in. And then you can specify when something happens, like those would be the actually source of events. And then you can specify SNS topic, SQS, queue, or Lambda functions. So in many cases, what happens is, because everything was possible before, but now, let me just highlight a couple of things. Pretty much, you can remove all that stuff. It's gone. Because you have Lambda functions which would be reacting, subscribing to a particular event and doing all this stuff. And you will save yourself probably a couple of bucks here and there just by using Lambdas. So start with Lambda right away, as I said earlier. And if Lambda doesn't do the job as you would expect, then start building the infrastructure. Even though it's possible, but having that system it just creates some complexity. It might look impressive. You would like to build something and substantiate your effort. It's up to you to decide. But if you really want to find as the minimum possible solution, which would do the job, kind of applying that Occam's razor principle, Lambda is the way to go. So streaming data is a very popular type of operation where you would have a source of data that are being generated in real time. It can be, I don't know, part of your Internet of Things infrastructure where you have sensors of some sort feeding information. It can be some tweets you are checking to celebrities posting some tweets so that you can react in real time. It can be some video that you would like to upload so that you can have some sort of a presence, like you will probably start building your new service on top of Amazon. And in essence, streams are like sequence, just byte stream, chunks of data, and potentially it would be everything is serialized, so you're not uploading just huge file right away. It would be being sent in chunks. It's being serialized or streamed, and there are lots of examples for that. So I guess the last bullet shows some of those. Mobile devices that generate geolocation every so often, every so many seconds. And that information is important if you would like to understand where your sales force is. Are they really at the client's location, or they're probably enjoying their time elsewhere? So use cases are quite diverse, that's for sure, right? And streaming is now possible with just capacities available with Amazon Kinesis. fully managed, scalable, which allows you to ingest buffer process in real time. So your streaming options are streaming processing options are analytics. You can just send them further down the pipe. You can view those streaming data as data streams where you would apply some data processing, or video where you can apply coding, encoding, viewing, storing, and maybe machine learning. It's another very popular use case because you can apply image recognition, voice recognition, and lots of good use cases. Whenever you use Alexa device or Google Home, pretty much that's what's happening. So whatever you talk to the system gets uploaded. They've got infrastructure which translates your voice into text. Text gets submitted, and eventually the system would get back to you with some solution. Maybe it will perform some activity on your behalf. And you can start doing it yourself. So data analytics for data is a very interesting capability where you can process data with sub-second latency. It has some built-in operations. You can build interfaces using SQL or Java. It has some primitives for you to extract in real time. So if you're familiar with Apache Spark, it's part of that distributed processing. They have streaming as well. So same story repeats here. So Amazon decided to implement the same model. It's serverless. Behind the scenes, they're using Lambda. They can cope, scale to your demand, and they provide real-time analysis with SQL. So whenever something happens, you can react to it with your own logic. It might be I don't know, like a fraud alert. You perform analysis of transactions. Let's say you have that online banking presence on Amazon. Just theoretically, if it's possible. And when you do so, you can have this fraud analysis done, or transaction or behavior analysis happening right away. You can implement also cross-selling. So whenever you feel that people are interested in a particular product, financial product, or otherwise, maybe some commodity product or financial product, you can, I guess, quickly suggest something which would be, in your opinion, a good cross-sell opportunity. It can be done real time. Firehose gives you the ability to provide the highest throughput of your data streams because it implements sharding. It can enlist additional resources as needed. And it has integration with S3, Redshift. As I mentioned, Redshift, it's kind of a data warehouse system, Elasticsearch, and Splunk. Splunk allows you to stitch together log files and other data sources together so that you can have a holistic view of trace down the path of every message coming through your system. It timestamps, it does that joining. You can also perform data transformation, so ETL on demand, if you will. You can strip certain columns, you can add some columns. Again, whenever you see serverless, think Lambda. And this happens in real time at very high throughput, right? So you can compress data, apply any type of a transformation, if you will, data encryption, decryption, if you use Kinesis Firehose. They support various formats like Parquet or RC. It's optimized record compression where your data, like think of a relational table where data gets stored column-wise, and usually column-wise values are very close in nature. Sometimes there's lots of repeats going on. They might be get offset by one or two, not very much diversity. So kind of the histogram, if you build a histogram on that columnar values, they would have very kind of a big pickedness. It's kind of the kurtosis would be very kind of it's kind of a big peak, or maybe some sort of a bell curve with small variance. So that type of data gets compressed very well, and that's what Kinesis recognizes, and that's what they use. Okay, and then after processing, your data is available for business intelligence and what's not. Okay, so that's a diagram. Just take a look at what it looks like. Okay, we've got, we can process video as well. So video, it's a little bit of an esoteric thing, but I guess before long we would realize that it's possible. If we start integrating machine learning with video, we can get so much out of it. I don't know, your branch clients, I'm talking about like a bank of some sort, like a virtual bank, if you will, a bank in the cloud. You can immediately recognize people walking into branch, and before this person asks, I don't know, whatever they want to ask, you already pretty much know who this is. Mr. John Doe or Mrs. Perkins, or whatever checking account they have and what's not. So it's a reality, and pretty much it's just not too distant a future. KVS use cases, as you see here, live video playback. So you can build your own, I guess, news agency, and you can broadcast live whatever happens in a particular part of the world in real time. It can be integrated, and lots of things can happen. And this is not some sort of futuristic view of things. This is a reality which is happening right now. And again, those are not distinct services which are working in isolation. They are very tightly integrated, and your code might somehow be spread across all those services. But the backbone would be managed services, highly available, redundant, in support of your logic. Developer tools. So far, we've talked about the capabilities available, and you would probably be thinking, okay, so what do I have really as a developer? In addition to those command line tools and SDKs, you have tools which are really focused on what is at the center of your interest as a developer. We've got the whole tool chain in support of continuous integration and continuous delivery for workflows, CI/CDs. So Amazon gives you what they call quite naturally developer tools, which have the following services: code commit, build, deploy, and pipeline. We will talk about each of those separately shortly, but the point here is that you can build your presence, your practice, your development practice in the cloud, wall to wall, starting from developing code, ending with your code packaged as an application, deployed in production, doing the good job. So your velocity increases, stability increases as well. Latencies, you can always enforce best practices. You can establish standards through governance practices and policies. All that is possible, and it's quite natural. Again, it's just one-stop shop. And that's what it looks like in reality. You've got release steps. We start from producing source of our program, committing it to a repository, Git repository. Then on commit, a build process would be invoked, which would enlist the services of a third-party tooling, which you have to plug in for testing. And when you're satisfied, you would be able to put it into production. So everything happens through that code pipeline from left to right. So that's what it looks like in the Amazon Management Console. Code build, source, deploy, each of which has its own sub menu options, quite extensive. So code commit gives you that Git compliant code repository in the cloud. And what's interesting is that you can use it in the cloud, or you can also clone it and use it on premise. And whenever you want to post updates, you would use the code commit deployed in the cloud. You can do pull requests, you can do commits, merging, pretty much whatever you would do with Git. It's kind of your GitHub, your own enterprise solution. Scalable, and it's secure as well. You can access repositories using the standard Git client. The lowest is shown here. It might change. Generally, the way you would work, you would clone it, and then whenever you want to post, you would use HTTP, HTTPS. It's secure. Code build allows you to build automatically in response to a specific event. It might be code commit, or it might be build on demand, if you will. Source, you configure everything either through command line, or better still, use the Amazon Web Services Management Console. It's just a browser-based wizard where you just fill out what you would like to use, what would be the build machine. You specify the Docker image configuration, what you would like to have, maybe certification certificates if you want, environment variables, command scripts. Everything is just a part of configuration of your build process. And when you're done with it, you can execute it for execution by simply executing AWS commands, the last bullet. AWS, start build, specify project name. And that project was configured in that wizard. So when you do so, you have lots of added value services, such as build history. It's good for auditing. So how many fails we have, how many successes, how many builds were done. You can do view logs, and you would have build metrics across that timeline within 1 hour, within 1 week, build duration, and what's not. So you have great visibility. It should be in line with lots of best practices that you have. And it's just in one place, because code build would be running alongside the code commit. So whenever there is a commit happening, code build, again, can be triggered, and you can start building the process. Tightly integrated, secure, and magically that CI, continuous integration, continuous deployment is becoming a reality. Code deploy allows you to target your deployments on any of the compute services that you specify. It can be ECS, EC2, Lambda, or your on-prem servers. So it will be kind of a reverse. You essentially push the code to your on-premise server. Downtime and time is decreased. What you do is you create a user application, and that user application would, again, bundle all that information that is required for code deploy to know what you would expect of it to do. Code deploy configuration, so it supports blue-green deployment. If you're familiar with that deployment arrangement where you have two production environments which can be swapped one for another, it's not for high availability. It's for uninterrupted deployment. So your blue environment production handles all the production requests and client, and you deploy new code into the green environment. You do some smoke test, you do some quick run, seeing that it's all to go, and then you swap green for blue. Essentially, green would become blue, exposed to production workloads, and the blue would become the new green. You pretty much can use it as a backup. If something like unexpected happens, you can swap it back so that the old code can be available. And everything happens quite transparently. That rerouting is very critical. Rerouting is people wouldn't really know they would be hitting the same DNS, but the IP address at the backend would change. All those things are happening transparently. And in addition to that, Blue Green in itself, it's just was quite substantial, I guess, for users. They have predefined in-place deployment. You can deploy all at once. That's what you usually do when you deploy your code. But at the same time, you can split your deployment in two halves, or one server at a time, meaning that you have a very fine-grained control of how you deploy your solutions. Okay, guys. By the way, those guys who want to drop off, I would suggest to you, I'll ask you, right, to complete evaluation form, because we want to hear from you what you would like to know more. So that's what all panelists and attendees write. It should reach you. It should take you 1 minute. I said, if you feel that it's probably be worthwhile to take training, we've got classes for Amazon Web Services, for architects, for developers as well. Code pipeline brings everything together. That's where you've got the whole workflow consisting of all the CI/CD stages, right? And it can use Amazon Cloud Watch events. It can do kind of many of the things that you would not expect. But generally, whenever you commit your code into repo with code commit, build would dig it, testing if you have it, was followed by the code deploy. So you just need to specify stages, specify the source, build and deploy. And what's interesting, you have already got those services in place for you. You don't need to go, okay, build. Where do I have build? Okay, I've got that build old machine, but that guy is on vacation. So what do we need to do? What is the password? Things like that. Now you've got one in one place. Probably you can avoid that lockout by a guy being on vacation. And CodeStar, it's the real deal when you start working with your code. So CodeStar is what you will be facing most of the time. It's just a way to integrate your environment, your development environment on your local machine with Amazon. And it has all the integration with the code pipeline. You checking your code, the build would be done. And they support a variety of languages. And as you see, you can find your own language choice. And your deployment can happen in a number of environments, elastic beans. So that's what it looks like, a little bit blurred picture, but what it does, it allows you to, you get SDK, you deploy it on your machines, and then you start kind of a building integration where you would have everything seamlessly integrated. It would be some sort of a continuum between your development environment and the cloud. In the command line, you will. There is nothing wrong with it. Okay, so what is a class code? Class code is, you would be asked to enter the class code. When you click on the link, it will ask you, because this webinar is a class. identified by code. You copy and paste that thing into the window, select final evaluation. There will be a bunch of radio buttons, click, 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 probably 20 seconds, and you're off of that thing. Team collaboration, again, all the best practices have been implemented already for you. So you've got integration with Jira, collaboration system. You can use Jira Cloud for free, or you can use your own license. You just point it. Sometimes it's just a little bit not kind of transparent. They don't host it. It will be hosted by Jira, but they just create a view as if everything just tightly integrated, and that's the good thing. So you can report on issues, releases, Scrum projects are supported through Jira. So you have a backlog, sprint management, and everything is again in the cloud. It's one point of contact, and lots of things become much simpler, and you are in the driver's seat. You are empowered from those. Okay, so it's time for questions. If you have any. By the way, this link is available for clicking when you get that PDF, or maybe not. Generally, visit WebEdge Solutions and webedgesolutions.com will give you all the upcoming classes and all the repository of classes. So questions? Yeah, we have enough time for any questions that you might have before we finish today.